Data structure using C++. Module 3 topic dictionaries. So as name indicates dictionary, a dictionary is a collection of pairs of the form k, v. Now normal dictionary which probably you might have used, Oxford or Cambridge dictionary, you will be having n times 1000 number of words with a values. Now think as if a word is a key. So its data type, like in your regular dictionary, data type is a string, a set of characters, and each of this word is having a different meaning. So literally in this programming language definition, they are nothing but a collection of pairs of the form k, v, and k is a key value, and v, we call its associated value for it. For example, you can think as if key being crane, which is a word, and the meaning of crane would be it is a bird. So meaning is bird. So that's one of the example of a dictionary element. So each element is of this form. So we talk now as a pair. The elements of the dictionary will be of the form of a pair. It will not be one number, but it will be two in number. And since we have a pair now associated, now how do you check a particular pair? How do you find whether that particular pair is available or not? So we do not have to use two parameters, rather we will be using, to get back the pair, we will be just using the key. Based on the key, we will search whether the dictionary pair is available in the database, or whether the dictionary variable has to be inserted where, or whether do you want to delete a pair in the database. These are some of the functions which are essential when you are constructing a data structure like dictionary. So these are some of the operations which is interest. So check whether the dictionary is empty. So empty function you can use. Determine the size of the dictionary. So number of pairs, how many you have. Then these three functions we will talk about today. How do you program this? What is basically the program to compute or find a pair consisting in the dictionary, and also how do you insert a pair into the dictionary and erase a pair into the dictionary. So this is kind of an introduction to dictionary. Later we will talk about some of the effective methods to find, insert and erase an element in dictionary. Right now the regular method, which we call it as a linear representation, or even you can use linked representation for inserting, erasing or finding an element, or searching an element or pair in a dictionary. Fine. Then again in dictionary we have one more method which we call it as dictionary with duplicates. So in dictionary with duplicates, for example, we consider that the word bird, a crane is a word, crane is a key. So you could afford to have two keys, and the meaning of each of this key would be different. For example, you can think as if keyword is crane and its meaning is a bird. Similarly, a crane could also be a system which is used to move an object. So here, since you're having two keys, same key is repeated two times, so there is a duplicate in the key number. So dictionary with duplicate is a method wherein you have a permission to have more number of keys, not one key. You can have two keys with different values, two same keys with different values, so the meaning is different. Similarly, you have literally tons of words with two different meanings, right? Similar words. Fine. So that's how we define dictionary with duplicates. So in this module 3 we will give more importance to dictionary. Dictionary with duplicates is not probably explained in this concept. So next, basically, this is a kind of an introduction given to a data structure dictionary. We have ADT for a dictionary as follows. As addressed in the previous slide, some of the methods which we require: empty, size, find, insert, and erase. And they are some of the functions, operations. And here instances is a list wherein each element in a list is a collection of pairs, or it is a pair. It is a pair with the distinct keys. When we talk about distinct keys, you will not be considering dictionary with duplicates. So it's just a dictionary with unique keys. Unique keys. Fine. So just observe: empty, size, find, insert, and erase. So what basically empty does, returns whether the dictionary is empty. Size computes the how many number of pairs you have. Find returns the pair with a key k, and insert adds a pair into the dictionary. Erases to delete a pair with a particular key. Fine. Now similar to that, similar to ADT, which is not program dependent, here you have a program which you call it as abstract class. This is not your implementation, or call it as a implementation class or a concrete class. This is abstract class. Concrete class, we define the rules, we define the program, syntax and semantics is defined, logic is defined. Here we just invoke it, we just use it. So nowhere you have any functions happening. So this is just initialization kind of a stuff. Use the name and set its value to 0. So this all are virtual functions, all are virtual functions. Now this is a bit interesting stuff: linear representation of dictionary. So remember, if we want to create a data structure like dictionary, what we will do is we will think as if the pairs are already available. The data structure dictionary is already available with us, and the pair, what we call, which has elements, keys, and you call it as values, they are sorted. They are sorted, which means you can either use a sorted array and sorted a chain. Sorted array and sorted chain is not included in your syllabus, so I'll just tell you how the pictorial wise how this looks. So we will be using, for this program explanation, we will be using sorted chain. In sorted chain, since it is a chain, so we will be using linked representation for constructing the dictionary elements. So in linked representation, each node would have 3 fields. Each node would have 3 fields, and the node we call it as pair node. Okay, and it will be having key and e values. Each of the node will have these fields, and also there will be a pointer. Third field, we will be having a pointer. It is a field next field is a pointer, so which will be pointing to the next node. So this way we define a template node. Fine. So I repeat, I'll just show you the pictorial diagram. So this is how the structure looks like for a template node, pair node. Pair node will be of this form. So we'll be having element dot first field, element dot first field. Why this is required? This space, this region will be storing the key value, which means the element dot first data type could be anything. So if it's a dictionary which you are constructing, then the first value will be always a string. And this is also, second value is also a string, because here this is a word and here it will be storing a meaning. So this would be string, this will also be a set of strings. And next, this will always hold the address of the next node. So 3 fields will be having this form. So this is one example wherein we address this word, but the first element could also be a integer number. So in the following discussion program, we will consider that the key is always integer. I will consider that the key is integer. It is not word, no more it is a word, and instead it is a integer, and this is a string. So this is your field. So sorted chain, what is sorted chain? Sorted chain, you observe that the key is sorted. Key is arranged in the ascending order. 4, 5, 6. So this is how the structure of sorted chain looks like. So if you follow this rule while constructing your chain, then it would be easy for us to figure out or check whether which element we want to pick, where to pick, and also how to delete. So we will be using sorted chain representation. Normal chain representation, there in that case the key is not sorted, but for sorted chain always the key is sorted. Hence we take key as integer. So it will be easy for so this example depicts sorted chain. You have three nodes, three pair of nodes we have, and each node has values 4. What is this for? 4. You think as if this is your 4th semester subject, S&S. 4 is your key value, which is the 4th semester subject is S&S. 5th semester DSP, and 6th semester data structure. This is the end of the node. So this link is not pointing to any other node, so you can omit null. So it's saying that this is floating. This is floating. So even you give null here or you leave it, no problem. That is fine. So this is how the template structure looks. One example, and this is a pair of a node. Fine. Now let's look at 3 programs. One is used for finding an element in this sorted chain. Suppose if this is your data, 3 nodes you have, and say that you want to sort this, or you want to find whether a word or whether the key with phi, that is this phi and this information, this pair phi and DSP information I want to return. So what basically you can do is you have to create one node which we call it as a first node, and let it point to, so literally whenever you're using a sorted chain, remember first node will be there always, and it will be connected to the first node. This pair node, this will be connected with the help of a node known as first node. It will be implicitly set, it will be there in the data structure, so you do not have to create it. Okay, so we check first node will be pointing to this. Then what we will do is we will traverse this node throughout the list, and we will compare. Each time we traverse, we check the key element with the key element. This key element, we can refer it using element.first. So element.first is actually the field located for key. So always do compare element.first with the key, because the key is actually the user entered key. So the key is always compared with element.first, and if it's greater or lower, we have to traverse. So here, if it's not equal, then you have to traverse. Keep on checking the key value with element.first. So for traversing, you can use this first node. If it's not equal, keep on traversing the node. So we can use current node, and we can change the node pointer. So instead of pointing it to second, we can, it was pointing to first node, you can make it point to the second node. Then you can move ahead with the same step. So by doing this, you can search whether the key is valid or not. If it's not there, you can just return null, saying that you don't have that particular key which you are going to search. Now let's see the program. So this is your program, template class K, class E. So basically K is the data type for your key, the key, and in this topology we have used K as 4. Key is having a data type integer, so K is int. E is string in this case, because subject name, so it's an DSP, so they are string. Fine. So sorted chain, so it says pair pointer, so it is going to return a type of form pointer. It is returning pointer, which means while returning, so it is of the type pointer, so it has to return address. So remember, using the pointer, we will be accessing the pairs, both information you can get it. So it is returning pair pointer to the pair. Okay, and here sorted chain is the function name, and using scope resolution operator, find function is written outside, which means find method we are working with here. This is a find operation belonging to sorted chain. Sorted chain is a chain wherein keys are in the sorted form. They are arranged according to ascending order. So what basically you're supposed to do, you can read out this line, but I'll not explain that. So let's move to this pictorial diagram. So first what we need to do is we need to set the current node to be equal to first node. So when we look at this figure, this is actually the method addressed. So first node is pointing to the starting node. So the key value is 5 now. So what is the key? The key is actually this value. So constant the key, which is 5 key you are supposed to search in your chain node, which is having 3 nodes with key values addressed as 4, 5, 6. So definitely you can see that it is available, that particular key is available, and it is available at the location C. Second, that is node 2 has that key. Let's see how this will be used, or how you are going to return these 2 pairs, phi and DSP. This pair, how it is getting returned. So first we set current node is equal to first node. So since it is a pair node pointer, a template based k comma e, we know what is k comma e now. So pair node pointer, so we have to create a node pointer. So this is your node, pair node pointer Cn, and it is pointing to a pair node. This is your template pair node. Now first node was pointing here, make Cn or current node point to the same node. So it's pointing here now. So now what we need to do, through Cn, so suppose if I use Cn with it, since it is a pointer, using arrow mark, I can access these 3 fields, element dot first, element dot second, and next, using Cn. Okay, so current node. So first what we'll do, we will, to check this element, how do you get 4? So we will be using current node or front node. We will use current node always. So current node, arrow mark, element dot first gives you 4. So that number has to be checked. So you have that here. So we check, once we create, we use a loop. So this loop will be repeating. Once if it's true, then only this instruction will be executed. If not, it comes out, and if condition will be executed. So here we use current node not equal to null. So when you look at this, is the current node pointing, or is it floating? It is not floating, it is pointing to a pair node, so it is not null. That is correct. It is not correct. And also we check the second condition, is the current node element dot first, you have 4. So 4 you match it with key. So is it not equal to the key? We check. So when we observe that, yeah, definitely 4 is not equal to 5. So what we need to do is we need to move to the next node. That's not your item which you are going to search. So you have here current node is equal to current node of next. So current node of next is this field. So this has to be changed. So change this current node. Current node was pointing to the first node, make it point where current node of next points. So current node of next was pointing to the second node. So change this. Now current node will point to second node. So this will be the link established. So it is not shown. Okay, so Cn will be connected to second node. That's the construction. The next, what we have now, the node is changed, current node is changed. Then again we compare now, while current node not equal to null, so you're in the second node, we are checking the second node. So current node is not null. Definitely you have elements here, so it is not null. So what we have to do, so just again check, since you have got information there, check the information which is the first field, element first field. So what is the element first field? So the element first field 5 it is, and that should be compared with this. So it is it not equal to null? No, it is equal to null. So this is 5 and this is also 5, so it is equal to. So this current node will not be changed now. So you stay back in the same node, because 5 is equal to 5. So you come out of the while loop. So you come out of the while loop and you execute this condition. So now you have verify the match. So if current node not equal to null, so we are in current node is pointing to second node, so it is having a information, so it is not equal to null. And check whether the current node dot first, is it exactly equal to the key? So 5 is equal to 5, so it matches. So in that case you have found the match. When you have found the match, return this whole structure, current node of element. Current node of element is this 2. Element is a structure with two fields, element dot first and element dot second. So now we are here. So this whole element structure, using current node arrow mark element, return its address you return, because we are making use of pointer concept. So return its address. So return address of current node element. So using pointer we can access it. Program access, we can access using pointers. If not, return null. So that's what it does. So since you have a element here, so it is going to return this whole pair. Suppose if the situation was, suppose you had a element something like 3, then first node it will check, you don't have, so it goes to the next node, again it checks here, current node it will check with 3, so it is not equal, so again you traverse, again you check here, 3 is not equal to 6, then finally what you do, you go back here, check the condition whether the first value, final node, when you're in final node, because you don't have any node, so it becomes null. Current node becomes null when you're moving here, right? So when you're over here at this location, if there is one null field, current node becomes null, right? So either it might be when it reaches the last node, here in this case it is floating, current node becomes null. So in that case you don't have any element, so in that case no need to traverse, that is your last. Okay, so it will not be executed. You come here again, you don't check current node will be equal to null, finally you just return null itself. Suppose if you're having here empty node like a null, okay, empty node if it's null, so you traverse, finally you will be reaching at a empty node which is a null. So that's what current node is used for. So this is an example, how do you find whether the key is available or not. So if it's available, return the pair. Next program we will see, which is to insert an element, and this program is bit lengthy, but can understand it. It's not that difficult. So to explain this, what we do is we consider that we have only 2 nodes now, 2 nodes, 4th sem S&S and 6th sem data structure subject. Okay, and this is the final node is empty node, so it's floating. Fine. So let's go back to the program. So what we are supposed to do now is we will be creating 2 pointers, pointer, trailing pointer and current pointer. So this TP has to be trailing 1 unit back, and P should be ahead of TP. Okay, TP will be trailing by P by 1, which means P will be always leading TP by 1. So why this TP and P? Both are required, so this would give you the track where exactly you are supposed to place the node for inserting. So this will assist you to insert a node in a position determined by P and TP. So both are essential here, because we are creating a new link and we need to destroy the link, and those links are obtained using these 2 components. Now this example, let us look at the concept wherein a new node, that is something like this node, you are supposed to insert, how this gets inserted. So before running the program you have just 2 nodes. After running the program we have 3 nodes, and this DSP has to be inserted between S&S and DS, because that's actually the exact location where you will be stuffing, because sorted chain always the key will be arranged in a ascending order. So 4 and 6 you have, so 5, this is actually the correct exact position where you are supposed to insert this node. Now let's discuss the program. So first you have sorted chain, insert function, pair k comma e. So first what we do is sorted chain insert function, we create first P node which is pointing to the first node, then we define TP which is empty, so that is defined here. So we create a node, this program, P is pointing to first node. So this is the situation, first node you had I have not addressed it. So always you will be having first node for a sorted chain, and P is also pointing to the same node. And we make TP null now because this has to trail by 1 unit. So now it is null. But P is pointing to the first node. Now next we check the condition while P not equal to null. So is P not equal to null? So when this is the case, P is definitely not equal to null. Okay, and it's having this information. It's linked to second node, and there is information in it. It is not null. So if there was nothing available here, or if it was floating, then it would have been null. Now you have information, so P is not null. And P element dot first. Let's discuss what is the pair before. So here you are inserting this. The pair has to be inserted. The pair has two features: the pair dot first and the pair dot second. The pair dot first is having phi. The pair dot second is having DSP. So this is a pair itself with the two features. Okay, so that we will be comparing here. So first, based on the key, we compare again. Values are not used. So first we check while P not equal to null. So you are in the first node, it's not null definitely. P element dot first, check whether it is less than the pair. So in this case, definitely the element dot first or element dot first field, you have an information 4, and the element which you want to insert, its key element is 5. So definitely 4 is less than 5. The condition is true, so you are inside this loop. When you are inside this loop, now what you have to do is, whenever you figure out that the first element dot first is less than the key which you are gonna insert, then you have to traverse, which means update the link, move to the next link. So TP becomes P. So now the next case, TP was pointing here, make TP point where P points, and update this, the P which was pointing here, make it point to the second node. So TP will be pointing to the first node and P will be pointing to the second node. So as we discussed, TP should be trailing by 1 unit to P, and that's what is happening. So to change the position of P, what we can do is, we can see that the first node, its link is connected to second node. So the way where the next is connected of the first node, there you make P point to. So we get that field access using information P of next. P of next is this link. So there P should point. So we will use P is equal to P of next. That's what you have. P is equal to P of next. So now the pointer is updated. So P which was pointing to the first node will point here now. So you have this as the settings now during the first iteration. Now again you go back and we check this condition while P not equal to null. So definitely P is in second node and it is not equal to null. You have information here, you have information. So this, don't consider this is floating. Think as if it's floating. So don't think as if this is null. Okay, this is connected to no node. So we have written it as null. Just you can erase this also if you're getting confused, but you have information. So this is not null, that's correct. But we check it's not null here. This is the program, and element dot first less than the pair we check. So what is element dot first now? So element dot first, so you have a value 6 here. Element dot first 6 value you have, and the key, the pair dot first, the pair dot first is 5. So you check 6 is less than 5 or P element dot first. So this condition is true, right? It's false. Why? Because this is 6 and this is less than 5. So 6 is greater than 5, though this condition will not be executed, which means you stay back in the same node. You stay back in the same node, and that is actually the current position where you want to insert. So this is not executed now. You know, no more you change the value of P and TP. So P and TP stays as shown in this diagram. Next, we look whether that is actually the current node. So what you have now, P not equal to null. So your P is located here. It is not null definitely, and let us check whether it is actually equal. So we check whether the P element dot first, is it exactly equal to the pair? No, it is not equal to no pair. Suppose if it was equal, for example, think as if instead of 6, we want sixth semester you have arm subject, so think as if sixth I want arm to be stuck here. Then you can use this method. Now when the element key is already available in the data structure, then replace the second element, which is its value. You can replace it, sixth semester arm, you can store it. So right now the key is different, it is different and it is not matching to this, so this condition will not be executed, is equal to, which means you will go to this condition and here you will be creating a node. Now what you do is, just forget about these two nodes, you create a new node, this is your new node, and the information what you are going to be inserting, that information should be put in this two fields. So what we will do, we will write create a node and create a node with two arguments, the pair and p. So what this does is, the pair node is having two arguments. Now the pair again is having two arguments. So what basically this does is, it creates a pair, it creates a new node with two information, that is phi and dsp. This is for key and this is for value, and also it will ensure that this particular node will be connected to where p connects. Where p pointer is connecting, there this newly created node will get connected. So you have created a node now, and this is connected to where p is connected. So p is connected to the second node. Now you create one more node. So now you have two nodes which has been connected to this node. So p is connected. So where p is connected, there you create a node, add a information and make it point to that node. So this is done now. After that, what we need to do now, here this link is not connected. So how would you get this link? So this link could be created with the help of TP, because TP of next is pointing. Earlier it was pointing to this node. TP of next was pointing to here. What you need now? Now this link has to be broken and it has to be connected here. So that's what is done in this third figure. So connect first node and second node using TP of next. That's why we use TP. So we use here, first we will be checking whether it is actually the first node. Okay, so if it's a first node, for example, there is a chance that now that's not the case. Suppose if you are having only one node, then where you will be inserting it, front or back. So in that case, this condition will be used. So if you are having only one node, then this will be executed. Right now already you have two nodes and one more node you are adding, so this condition is false now. So if you are having two nodes, then else TP next is equal to new node. So TP next will be pointing to new node. So new node is here and make TP next point to new node. Okay, so that's what is done here, and this will be the program. This is considered. Similarly, you just analyze this program. So after that, what happens, d size will be d size plus plus, so increment the size. Now you will be having three nodes, so you can try with different parameters. The same program will work fine. You can try it out with the one node. Consider one node, you can give that an example, see how this works. In that case, this will not be executed, so this is correct. Then you work here, you won't traverse because you are in null. Then finally you reach here and we create first node as a new node, and it is first node which you're going to insert. So first node will be new node itself. So increment the size. This is when it is null, sorry, I mean this will be executed when there are no nodes, sorry, not one node. First insertion, this will be the scenario. First node will be the new node itself. Fine. So the last program which we will look at now, how do you delete an element? How do you delete an element from this configuration? I'm supposed to delete DSP, which means ultimately I should be able to get this structure. So let's discuss using this pictorial representation what we are supposed to do. So first what we need to do is the key will be given. Phi is actually the key, and the pair associated with phi, which is phi and DSP, has to be deleted. So to do that, again we will be using TP and P. Again TP and P are used to provide you the track which node exactly you are going to delete. So now the situation is you have the information which you are supposed to delete, it is in the second node, so this you are supposed to destroy. Suppose if you want to destroy this, just observe the second pictorial diagram. So what we will be doing is this link which was connected between second and 2 has to be destroyed, and we need to connect this link back to third. So connect the link, first link to 3, and destroy this using a pointer. So what we can do, we can use TP and P, which we had used even for insertion. So ensure initially P is connected to the first node and TP is trailing, then traverse it, check the value 4, compare it with 5. So if it's not matching, then traverse, move ahead. Suppose in the second node, again compare. Suppose if you are getting the same answer, then what do you have to do? So P will be pointing here and TP will be pointing here. Check TP of next where it is pointing, and check where P of next is connected. So P of next will be connected here and TP of next will be connected. Where P of next is connected, there you connect TP of next. So that's what we do. And finally P is a pointer which is connected to second node, and you can delete that P. That's the process. So this will go, and finally you have a connection between 1 and 3. So 2 is destroyed using a pointer itself. So that's the process which needs to be looked at. So let's discuss the program. So you have sorted chain, erase, constant k, the key. So now the key value is 5. So 5 is actually the pair, 5 is the key which you are going to search. So here you don't have a pair, you just have a value, the key value 5. So first, as addressed previous, so create two pair node, star P and star TP. So P is a pointer pointing to pair node, and TP is also a pointer which is pointing to pair node. So first P is connected to the first node, it is pointing where first node points, first node is not shown. TP is pointing to no node, it is not pointing to any of the nodes, so it is null. So this is pointing, this is not pointing. Now again you check whether the information 4 is it exactly equal to the key value, which is done with the help of a while condition. While P not equal to null, so P is connected or it's pointing to the first node, so it is not null, and P of element dot first is less than key, you check. So what is element dot first? So it is 4, and what is the key value? It is 5. So 4 is definitely less than the key. So what do you have to do? Looking at this, you think as if 4 and 5 is greater, so traverse, go to the next node. So we use TP is equal to P, so TP becomes P and P will be P next. So that's what happens here. So TP becomes P, where P is pointing, make TP point there, and P will be pointing to the next node. So next node information you'll get it through P of next. So P of next is this link, there you make P to point. So now this P is gone. P was pointing here, now no more it points there, it is pointing here now. Now you just check again the information present at the element first and compare it with the key. So the element first is 5 and key is also 5. Now you just go back. While P not equal to null, this condition is executed. Definitely it is not equal to null. Then again second condition which you are checking is less than key. So 5 you have, 5 is not less than 5, it is equal to. So this condition is broken and you come out of this while loop. Okay, you come out of this while loop. So now the status is TP is pointing to second node and P is pointing to second node and TP is pointing to first node, and your element which you are searching is in the second node, and that should be deleted. Let's see how it is deleted. So first we verify the match whether it is equal. So P not equal to null, that's correct. P is not equal to null here, P is not equal to null. Then we check P element dot first, is it equal to key? Yeah, that's correct. P element dot first, which is 5, it is equal to the key value which you are searching, it is equal. So in that case this condition is executed. Now first we check if TP is equal to null. What do you mean by TP is equal to null? So TP will become null, so if you are having only one node, okay, or if you are having no node also, TP will be null, correct? TP will be null. I will go here, TP is equal to null, we set it. So right now TP is not null, so it is connected to the first node. So if you are having only one node, we can think as if this condition checks. So you try with a program wherein you have only one node and try to trace this program how it works. So in that case, probably this might run. Now the condition is inside this statement is false, this statement is true. So we go with else condition because TP is having information. Else condition is executed now. So TP next is equal to P of next, where P of next point, so P of next is pointing here, there you make TP next to point. So this is the pictorial diagram. P next is this link, second to third. TP next was here pointing. Now make it point where P next point. So 1, 2, 3 we have created a link, right? And after that, why we want to delete this? So to delete that, just delete the pointer. So P is actually the pointer which is pointing here. Just delete that. So this whole information will be destroyed and this link will be removed. So you have a cross mark over here. So that is done using delete P. Then since we are deleting an element, a pair, we will be using the command dsize minus minus. So what does this mean? So previously we had 3 nodes. Now we are having 2 nodes. So 2 dictionary elements we are having. So this is the program for deleting operation. So ensure that you have a pictorial diagram, something like this, so that you can understand the program in a better way. So every slide whichever I've addressed here, make a note of it, and this diagram, if required, you can take it, work upon it, so you'll come to understand what exactly happening. And also ensure that you take different possibilities. To just take 3 elements. Take what if the node is 0 and null, what if you are having 1 node, what if you are having no nodes, 2 nodes, 3 nodes. Then think as if ultimately this program, whatever we have discussed today, the insert, delete, and also the find operation, it should work for any possible case. It is not specific for one program, it is in general program. Fine, we will look at the next discussion would be hashing. Hashing for it is an effective method to handle dictionaries. I'll discuss that in the next class. Thanks.